Chapter 8, Functions. Hello everyone, and welcome to Browning's Introduction to Programming with Python. And we are on Chapter 8 of the 5th edition, Functions. Functions are something that is going to make your programming life much, much easier. Alright, in the life of a program, there could be numerous sections of code that might need to be coded over and over again, or called repeatedly. Maybe it's an error, maybe it's a beep function, who knows. But considering this, would you want to rewrite that same piece of code over and over again every time you needed it, or would you want to have a chunk of code that you could just literally jump to and have it execute that code, then come back to where you were? That is in fact really what a function is. So reusable code. We'll call them functions, methods, function procedures. We'll go into a couple different more specific names for them. Depending on the language you're dealing with, they may be a bit ambiguous about how they define things, such as Java. But we're in Python right now, and we're going to say the best bet is to functionalize your code and to write a code segment once and then just call it as many times as you want, as needed. And it also makes editing a little easier and modification of your code. So writing these segments, these code segments, will allow you to easily make changes. You only have to make changes one place versus several. Easily reuse code in other applications. Make your code easier to read. These benefits, alone are pretty amazing. A little overview. Let's talk about a subprocedure or method versus a function. For this text, and for a lot of text, but not all of them that you'll read, a subprocedure or method just performs a task or a series of tasks. All right, but it does not return any values. We're going to come back to that here in a minute. But it does not return any values. It just does something. A function, however, returns a value to the caller, or the calling method, or calling function, calling line of code. An event procedure might also be associated with what we're talking about in this chapter. For example, with a GUI, graphical user interface driven application, right click, left click, a drag, a hover over. These are all events or event procedures or mouse events or things of that nature. But for this chapter, we're going to be worried about subprocedures and methods per se, which we're going to consider the same, and functions, which return a value. All right. So in the next example, we have subprocedures and how to use the def function. Whether you use subprocedures or methods or functions in Python, they're all going to be def functions, and that is a keyword there. Define, definition, then the name of the function in question, and then in parentheses, does it take any arguments, or if it doesn't, it's just empty parentheses. In this example, what we've done is we've made a foo function, and the foo function just literally prints a blank line, then it prints hello world, then it prints another blank line. And then you'll see on the very last line, and notice it is left aligned, but it's tabbed over within the function itself, you actually call the function, just give it its name, and if it requires parentheses and an argument, you would give it that. In this case it doesn't, so it's just foo, left and right parentheses. Try that example out, and then we will move forward. Alright, very good. So you have got that function to work properly, and didn't do too much, but it did work. We can add to it. Let's try the hands-on, and let's change the code. Change the code you wrote to call the foo function 3 times instead of once. So you'll need to have foo, left and right parentheses, on 3 lines. Change the code that hello world is surrounded by asterisks. So where you have those 2 blank print lines, you could put some asterisks if you wanted to. And then get a little more advanced. Ask the user for their first and their last name, and then dump that into the associated function and have it print. Try that out and then hit play when you are completed. Very good. So we said some procedures or methods just do something. They don't return a value. So functions return a value. And what we're going to see is with a function, there is a keyword return. This is common across other languages. So the next example we have with functions, def your underscore number, and then look, it takes an argument, expects to be given a value, and then it says basically give that number back to the calling function. So what we see then is in our code then, this is the actual program itself. The def functions are just something like a library that we're calling later. Value 1 equals input. Please enter a number between 1 and 10. So the user enters a number between 1 and 10. Let's say it's a 1. All right. Print and your number was, and then we call within the print statement the def function, give it the value 1, which is 1. It goes up, 1 becomes number gets sent back, it replaces that whole entire statement such that what prints is, it ends up printing and your number was, space 1. Try that out and hit pause when you're ready to, or play when you're ready to move on. Very good. So let's see here. We want to look at hands-on more functions. Let's make an example here now that actually is a little more productive. It actually computes tax. Try that out and then hit play when you are ready to resume. Alright, now let's talk about pass by value and pass by reference. Pass by value, when you are passing a value in those parentheses up to a function, it is actually copying the value in our previous example from value 1 to number. So actually you have two variables now, value 1 and number, that both contain the same data. Alright? Pass by reference, or a reference pointer, it may have a different name, but it points to the same memory location. So it refers to where it is in memory. This is by value. So you might think of pass by value as a copy. Pass by reference refers to where it is in memory. It's still the original variable, even though it may have a different name. This is common across languages. So pass by value, very simply, when you pass a variable or something, perhaps a function, a copy of the variable is given or passed to the function. This ensures that any changes to the passed value are not reflected in the original value, as the changes are destroyed once the function is completed. So basically there's no accidental modification of the original value. Now, pass by reference, which is the only way Python allows, passes a reference to the original variable such that any changes to the past version are actually changing the original version. Not necessarily a bad thing, but it's just how Python happens to handle that. All right. So let us try an example of a pass by reference program with Python. What follows is an example of Python list, which is really a sequential storage area in memory. In other languages, an array would be a close analogy. However, even though this will be discussed more in detail in later chapters, let's try to see how this works. And we're going to make a list. We're going to extend it and add some stuff onto it, and hit play when you're ready to move on. Very good. Scoping variables. Alright, so scope you might think of as where you can get to something. Alright, remember from our study of variables that Python variables are immutable or non-changeable in the original location they're created in. So in this way, variables are bindings and not memory storage locations that can change over time, like with another language. Alright, because remember it's a non-strongly typed language. It creates the variable's type as you change the data. If you create a new variable x and change it to 6 in a new, different location, and type ID, remember we use the type command, is actually created in Python. Alright. Other languages do not work that way. Alright. So basically, with scoping, what you need to think about is a local versus a file level versus maybe a global variable. Alright, and again, these are somewhat differently defined depending on the language you're dealing with. But if we talked about a local variable in the next example, we said def foo, and then we said number is equal to 5. This is local and only accessible while you're in the foo function. If you were outside of the foo function, if there was another variable named number, it would use that value and not this value. A little strange, but it's going to make sense here in a minute. So what we've done is we've created a variable in foo called number, and we get a value of 5. But then note we've created another variable outside of the function called number, and we've given it a value of 1. So what in fact happens is the program really starts, for all effective purposes, it says numbers equal 1. Then it says print number, which is going to print a 1. It's going to call the foo function. It's going to get a 5. Then it's going to say print number, and guess what it's going to give? A 1 again. Why? Because we've gone out of the scope of the function, and we're back in the original scope where number is the one that we're actually dealing with. Hit play when you're ready to resume and you tried that out. Alright, and the next example we're going to try more on scoping. This is the change it function, and notice how the variable x is not going to change. Change y, a local variable, is not accessible outside of change it. Global variable x is still 3. Alright, so if you'll try this example out and then try the challenge, prove that y is destroyed. And how are you going to prove that? Well, when you try and print y, it's going to say, hey, I can't find y. But try that out and then hit play when you're ready to resume. Very good. So the next part of the text, we're talking about a little bit more on namespace and scope. It just gives you a little example there of how that works, but I'll let you read through that on your own. Hopefully you're getting a good idea how that's going. If you want to look at a couple of different types of importing things from another file, we can do that. What we have is, on the next example, this is your first 2-file Python program. So there'll be 2 files that are saved in the exact same folder or directory or location. One file named import_var.py, and one file that you're going to actually run, driver.py. Now, what we have, import_var.py, we have a variable, and again, back to that scoping concept, number equals 6, and then we have a function that's defined in that import library that we're talking about, def print_num, and it says print number. So it's going to print whatever's local to it, which is going to be, of course, number equals 6, right? Comments just there for you. You can leave them out if you want to. The driver program that you're going to run, this is the interesting part. From import_var, so we're telling it the file we want to import from. Notice that the .py is implied. Import space asterisk. The space asterisk is a nod to DOS or command line prompt terminal commands. Asterisk means anything or everything. So basically it says from import_var, import everything. And then it says numbers equal 10. So we got another variable with the exact same name, but it's 10. And then we say print_num, right? That's our function that we imported from the other side of the house. Hit play when you're completed with that and you're ready to move on. Alrighty, the next example, more on importing. You do not have to import everything. You could import only certain things if you wanted to. So, for example, we have a 2-file program again, import_var2.py, and then we have the driver. But now notice that from the import statement, we say from import_var2, import only the foo function. Try that out and then try the challenge. Try and use print num, and it's going to say I don't know how to use print num because you did not import it. You would have had to send, import asterisk. Otherwise that wouldn't have worked. Alright, try that out and hit play when you're ready to resume. Very good. Local variables, modulo variables, and global variables. Basically what you need to be thinking about with this is it local to a function? Is it modular to a file, or is it global to multiple files? Alright, that is probably the easiest way to think about that. So again, is it local to a function? Is it modular to a file, or global to multiple files? So think globally, not locally. Our surfer slogan might make a good t-shirt, but it's even better with Python. So if you look at this, we have a new keyword that we're using, global, and what that's going to allow you to do is create a variable that's not going to be destroyed. Alright, so try the next example out with globals, and you'll see that we've made this variable called num, global keyword, to allow access to the original number and not create a new one. So it's going outside of the scope. And then we will come back to look at math functions when you're ready to hit play again. Alright, math functions and the math modules. So most programs have a math library associated, or most languages have a math library associated with them. Python is no different. Basically, if you say import math, you will import the math libraries. Now, back to this whole scoping thing. We're talking about scoping. God, I'm so tired of hearing that. It's very important. All right. So you import the math library, and then what we're going to be able to do is tell it, oh yes, scope yourself to the math library dot notation. Here's the specific function I want. For example, when you try the next things out, math.cosine, math.pi, math.logarithm, okay? Try that out and then go to the challenge and look at some of the different math functions that are available. And in fact, there are other math functions that are available too. If you do SciPy, Scientific Pi and StatsPi and some of the other ones that are available, there's certainly others that are out as well. Find out what Python thinks the value of pi is. All right, how many digits does it go out? Try that out, and then we will look to the next section in the text. All right, very good. Let's see. How the computer handles math is pretty straight up, but we know that it's basically a binary system, and so that's where we're getting into an issue with some of the rounding. If you want to try the example in computer math, use the REPR function to actually determine the specific type that you're dealing with. The next thing that we want to try is the date and time library modules. These are super handy. So the example that we have in the text is from an interactive prompt, although certainly you could use a script mode if you wanted to, from date, time, import, date. But try the example out, and again, this is an interactive prompt, and try out the birthday. Try that out from a script if you'd like. Try a program out that asks someone for the birthday, and then it gives you how many days old you are. Hit play when you're ready to resume with random numbers, the cornerstone of any good game programming experience. Okay. Random numbers. So we have two types of random numbers, pseudo-random and real random numbers. Pseudo-randoms basically are simulated random numbers, and they're not really random, and you can't really guarantee their randomness, let's say. All right? They're good for testing applications because you can guarantee that they're going to generate the same random set over and over. All right? True random numbers have a seed value. Typically, this may be the current clock cycle on your computer. Depending on whether you're doing some cryptography work, they get more advanced, but you do your testing with pseudo-randoms, then you do your real work when you're ready to actually do the final test, beta, alpha test, do real random numbers. Don't do that though during initial design, work. So, from an interactive prompt, although certainly a script would work as well, we're going to do a little peek ahead here with some randoms and choosing between words and also numbers. Try out the random numbers example, and then try out the seed example as well. Basically, this is going to allow you to pick a random seed, so it should truly run differently when you run the program multiple times. Hit play when you're ready to resume. All right. Last thing that we will look at in this chapter is we'll look at a little nod to statistics and graphically visualizing data. A histogram is a visual representation of numeric data, and so what we're doing is we're actually going to create a chart of where certain numbers appear, and we'll see addition symbols representing the actual values. All right, try that out. Be very careful that you do mind your spacing. You may change your range and increase it, possibly. Run it a few different times. Try the activities at the end of the chapter. Use what you've learned to build on what you've learned, and we will look forward to talking to you in Chapter 9. Peace and tranquility, as Mr. Spock would say.